morning, or good afternoon, I mean. Welcome to Math 9 in the PM. Host, Joel Sandelic. We went over this in our previous lesson, 7.2, scale diagrams, reductions, and we're using enlargements as well. And the whole cross-multiplying thing is set up your fractions always with your scale measurement on the top, the original measurement on the bottom, and solve problems using our cross-multiply divide by the lower, which works only for proportions, as long as there's no adding or subtracting involved. That was previous class. Yesterday, we went over the assignment, all the answers. Now, then we took a look at the start of this second half. You guys missing basketball the other day? We did this scale diagram. We actually did the diagram using a scale factor of 1.5. We multiplied everything by 1.5, and then we drew it. This is what everybody should have out at this second when I look around. I'm going to pause the video while I make sure everybody's got what they need. This is where we're picking things up. We're going to do the second example on the sheet. Draw a scale diagram of this octagon. Now, I made sure I used the word octagon because octagon isn't just a stop sign shape. That's a regular one with equal angles and equal lengths. An octagon can have a cave part to it. This time, though, it's a reduction, and I know it's a reduction because the scale factor is decimal 25. If it's less than 1, it's smaller. So the first thing you guys have to do is get a ruler, and I'm suggesting, because they're all right angles, you get a ruler with, if you're hopefully getting your own geometry, get a ruler like this, right? Because then you can make the 90 degrees without measuring the project. So go ahead, and the first thing you're going to do is actually measure these lengths and widths. Okay, I'm going to pause it while you guys get measuring, and then we'll compare. As you guys are doing it, I'm going to write down some of these measurements. Okay, I'm going to check over my measurements. What do you guys use for this one here? I'm thinking it's 31. Is that about what you guys have? 31. Okay. Just because your ruler is actually probably more accurate. Okay. Yeah. Oh, there we go. That'll drag us out. Oh, secret. Okay. Doing the wrong thing. Can't handle this thing. Okay, there. Why did you go? Just in your lap. Do it, please. What do you guys use for the tiny end? The three little 16 each time? On my ruler, it does. I call it 16, but I noticed that it's just 15 point something, right? Because did you guys get 47 for the long length on the left? So you can see why it's probably like 15.7-ish. I'll call these 16s. Trying to write this right. So if this is three groups of 16 millimeters, is what I'm saying, and it's really 15.7 or 8. It really should be 48 on the left side. You follow what I'm saying? Because 16 times 3. I'm going to put 48 there, though, because it'll make it work. Either that or I call it 15.7. With rounding, though, that's how it works. Okay. Now, what I'm now going to do is the scale diagram. I need to do calculations for this. So, quarter, decimal 2.5. If I go with that, I'm going to go 47 times 0.25 and 31 times 0.25 and 16 times 0.25. Well, I guess in 48 too, because I invented that one. Because of the rounding. Really is 47-ish, but you know. Now, that's because the scale factor is a quarter, decimal 2.5. What's that? 48 on the left side. The reason why is because we have 16, 16, 16 three times. That adds up to 48, just to make it perfect. Measurement-wise, it really is 15.8 or 7 or something like that. So anyways, you guys got some math to do. You're going to report to me what the next measurement is. Decimal 2.5 from that table. You guys haven't done it. Naughty. Okay. Oh, I'm still waiting. They're going to be following along this. That's cool. Okay, I'm going to call it 11.8 because that's about as accurate as I can get with that. 1.8 millimeters. Okay, just wait, I'll check with other people. Okay. This middle zone here, so 31 times a quarter. So I'll use 7.8. Because I cannot go that accurate with millimeters. I can't go 7. Okay? You guys. How many times 16 times decimal? 4. It is 4 on the and 48 times decimal 2.5, the last batch, either max or Juicera. And you just told me, right? What was it? 12. Okay, this means anywhere you see a 47, you on the reduced one, you look at 11.8. Right? I'm going to suggest. Sorry. Oh, scroll up. Oh, not down. Yeah. Guys, are still chit-chatting. 11.8 millimeters is actually 1.12 centimeters, right? It's going to be pretty tiny. So here we go. I'm going with my 11.8. As accurate as this allows me to be. Your pencil is actually a little more accurate because it's a digital thing. I can't quite get it perfect. Oh, it's a little over. There's my 11.8. That's mine. You guys got it, right? And you guys have, and I told you guys to use your triangles to do your measurements. You can do your 90 degrees easy. I would suggest going with 48. 48 though is replaced by 12. So I'm going to twirl mine. So 1.2 centimeters, 12. Okay, there's mine. And then another 11.8 bottom. Then twirl. And I'm going to do my 4 and 4. Then I'm going to do my innards. Those 31s are actually 7. Well, that went way over just the way the digital marker works. So again, try that again. It's really hard for me to get this perfect lined up. Easier with a real ruler. There's my scale diagram. Mine is not very good. It's fatter at the bottom than it is at the top. And it shouldn't be. 16 here, 16 there. Should be 4 and 4. This. Notice my proportion isn't perfect. Okay. I do better when I use a pencil on paper. The way my digital hands work, and they don't line up correctly. Anyways, you guys should have your drawings done, right? Good. Okay, let's flip the page. Here's 2 drawings of a dog. They're done. You don't have to draw these. Yeah, it's the wolf. It's very hungry. Okay. Determine the scale factor of the reduction as a fraction and as a decimal. Remember, we use the letter K often just to represent that. So we're going to remind ourselves here, K is equal to the scale diagram measurement over the actual or the original measurement, right? So in this case, K equals. I'm going to take one measurement from each and compare them. If I look at this, I got here to here. That is a height of 1, 2, 3, 4, 5, 6. Well, I'll be darned. I can't do this by counting squares because the other squares are just smaller and it's still 6, right? Got to use a different method. What do I have to do then? I have to use a ruler, don't I? Well, luckily I have a ruler, you do too. Copy. Copy and paste. There we go. I'm going to choose the back end of that dog because I'm going with the longest because it's easiest to measure. So I think this looks like 28 to me. What does it look like to you guys though? Because your rulers, this might not be in sync with your ruler. I think it. You have, what do you have? 30? Okay. Your ruler is in a different. You see your photocopy and my photocopy. That's fine. I'm going to just stretch my ruler so it's 30 as well. Get the same measurement. Oh, I'll be darned, I stretched it too much. Okay, this is about right. So you're saying it's 30 millimeters on yours? Okay, I got it in the same scale as yours. So what is it? It is 30 or what? 30 on the big one, right? As long as you compare the same. So this one's 30 millimeters. And on the little guy, 15. Okay, that's what I'm getting to. Okay. So the 15 millimeters, which one do I put? Which one do I want to put on the bottom of the fraction? The 30 or the 15? Nope, I want to put the 30, the actual, the first one. Okay. So you assume the one on the left is the first one. So this is a reduction. So 30 compared to 15 on here. That's your fraction. And you can, and it's as a decimal, 15 out of 30, which is also 1 out of 2. You can put that. But 15 out of 30 is a fraction. If you put this in a calculator, it comes up to be decimal 5. Nicole, were you here yesterday? So we're picking up from that sheet. Okay. The next question we don't need a ruler to do. 8. Which of the rectangles, A, B, C, is a reduction of the largest? Justify your answer. Now, we did this in the textbook the other day, but let's see if it makes more sense today. This is 1, 2, 3, 4, 5, 6, 7, 8 on the wide side. The width, I call it. And the length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if it's an 8 to 12 ratio, that means it's proportional. It's a reduction of the other. Now, I'm going to write this down. K is equal to. No, it isn't. K is equal to. I'm going to write it down as a fraction. Length to width. Or width to length. I don't care which one. Now let's go width over length. That's this proportion, 8 to 12. What is that if you make it a fraction in the lowest terms? What can you divide 8 and 12 by? 4. The biggest number is 4. So 2 to 3. If the width and length are in a 2 to 3 ratio, when I say in a 2 to 3 ratio, that could be the same as a 4 to 6 ratio, right? 2 times 3 is a 6 to 9 ratio. 2 times 4 is 8 to 12. Okay, nothing's bigger than that. So reductions could be in that, and it could be even in decimals that come out to be 2 to 2. Now let's just see this. The first one. Now this is the width of 2. The width is 2. According to this, being the same ratio, we should have a length of 3. Does that work here in A? It's a 2 to 4 ratio. You'll never be able to multiply A by the same number to make it back to the original shape. You guys follow that? Okay. Now, B, the width is 3. Now, is there any way to multiply 3 up to 8 and then the same number as the 4 to 12? No, that doesn't. It's not in the same ratio. It's not in this 2 to 3 ratio. But this is in the 2 to 3 ratio. C is your answer. Why? Because C, 2 times 4 is 8. C's length is 3. 3 times 4 is 12. You can multiply by the same number and get back up to the original, or you can divide by the same number, get down to the reduction. I want you guys to do these questions here for the rest of the class, okay? 12, 13, 14, and then 20. Still going to